Hello and welcome to our new video in the data science series, and today we are going to learn about linear regression. In this video we will be discussing what simple linear regression is, how it works and how to use it to make predictions. At the end of the video we'll also look at a Python implementation using scikit-learn. And before we get started, don't forget to hit that subscribe button to stay up to date on all our future videos. So linear regression is a statistical method that is used to predict the value of a continuous dependent variable based on the value of another continuous independent variable. So dependent variable is something that I want to predict, and independent variable is something that can impact the output or the dependent variable. Linear regression is a supervised machine learning technique because here I know what is it that I want to predict. Now the goal is to find the best fitting line that describes the relationship between the independent and dependent variable. This line is called regression line. So for example, I may use linear regression to predict the price of a house based on its size, or to predict the demand of a product based on its price. Let's look at the type of linear regression. When I say type, this means how many independent variables are present in my dataset that can impact my dependent variables. So talking about simple linear regression, it's when there is just one independent variable and one dependent variable. The equation for the regression line in simple linear regression is y is equals to mx plus b. Now y here is the target or the dependent variable that I want to predict. M is the slope of the line, b is the intercept, and x is the independent variable. In terms of multiple linear regression, we have one dependent and multiple independent variable. So the equation for the regression line incorporates every independent variable that we have in our dataset. So in this case, the equation becomes y is equals to b0 plus b1x1 plus b2x2 up to bnxn. That means as many independent variables as we have. Here y is the dependent variable. That means this is what we want to predict. x1, x2 up to xn are the independent variables, and b0, b1, b2 up to bn are the coefficients or parameters of the model. These coefficients represent the contribution of each independent variable to the prediction of the dependent variable. Now there are certain assumptions that we need to keep in mind while using linear regression models. The first assumption is that there is a linear relationship between the independent and dependent variables. What this means, as the value of independent variable increases or decreases, the value of dependent variable will also increase or decrease by a fixed amount. The second assumption is that the errors or the prediction errors are independent of each other. That means the value of one error does not affect the value of another error. Here the error is the difference between the predicted and the actual values. The third assumption is that the variance of the errors is constant, which means the errors are equally distributed around the regression line. The fourth assumption is that the distribution of errors follows a bell curve shape, or they are normally distributed. Now let's talk about a few ways on how to fit a linear regression model. The first method is the least square method, that involves finding the line that minimizes the sum of square differences between the predicted values and the actual values of the dependent variable. This is the most common method that is used for fitting a linear regression model. The second method is the gradient descent, and it involves starting with the initial line and then iteratively updating the line until it best fits the data. Now let's look at how to make a prediction with a linear regression model. Let's look at this through the lens of simple linear regression. In this case, we will need to use the equation y is equals to mx plus b, that is the equation of the regression line. Here y is the predicted value of the dependent variable, m is the slope of the line, x is the value of independent variable, and b is the y-intercept of the line. Now the values of the independent variable can be used in this equation with the values of slope and intercept to solve for the predicted value of the dependent variable using this equation. Luckily, we don't have to do this by hand, as Python and R have packages that will do this for you. Now once we have fitted a linear regression model and we have found the values for all the coefficients, be it a simple linear regression or a multiple linear regression model, how do we figure out or how do we evaluate that the model is accurate or not? One of the metrics that can be used for evaluating a linear regression model is coefficient of determination, also known as R-square value. It provides you the information on the variance in the dependent variable that is explained by the independent variable. R-square values range from 0 to 1, with a higher value indicating a better fit. One thing to keep in mind is R-square value is useful in the case of simple linear regression, because as we increase the number of independent variables, the value for R-square will also increase. In this case, another metric called as adjusted R-square should be leveraged. Another metric that can be leveraged for evaluating the model is mean absolute error. This is the measure of the average magnitude of the errors in the predictions made by the model. It's calculated as the sum of absolute errors divided by the number of predictions. Lower values of mean absolute error indicate a better fit. Root mean squared error, or RMSE, is another metric that provides the measure of the average magnitude of the errors in the predictions made by the model. It's calculated as a square root of the mean squared error. Now, the lower values of RMSE indicate a better fit. Keep in mind that the error here is the difference between the predicted versus actual values of dependent variables. Now let's look at how to implement linear regression in Python. We start by importing all the required libraries. We'll be using the scikit-learn library, and we'll import the linear regression method from the scikit-learn library, as well as train test split for splitting our dataset into a training and testing set, pandas for working with data frames, and matplotlib as the visualization library. We start by importing our dataset, that is a salary data with the features such as years of experience and salary, where salary being our dependent variable. Now there's just one independent and one dependent variable, so this will be a simple linear regression, and we'll be working with the equation y is equals to mx plus b. To start with our model fit, we have to split the dataset into x and y, where x is the independent variable and y is the dependent variable. And then we go ahead and split it into training and testing set, where testing set is 20% of the data and 80% goes into training the data. Now, to look at a linear relationship between our dependent and independent variable, we use a scatter plot. And in this plot, we can see that as the number of years of experience are increasing, the salary is also increasing, and they kind of fit on this straight line. So we go ahead and pass the independent variable and the dependent variable values from our training set into this linear regression method, and we fit the model. The result is the coefficient and the intercept values, that is, the values of m and b. Now, to see how much of a variance is explained by the independent variable in the dependent variable, we use the R-square value, that is the coefficient of determination, and I can see that the 96% of variance is explained, which seems like it's a good model. So let's go ahead and see how the predictions look like and how does the errors look like from the actual versus the predicted values. So here I can use the predict method and pass the independent variable values from the test set and get the predictions. Now here, to see how actually my values look like and what is the difference between the actual versus predicted, we look at the root mean squared error, where the lower value means that the model is pretty good. Thank you so much for watching. I hope this video helped you understand more about linear regression. And if you're interested in learning more about data science and data analytics, don't forget to hit that subscribe button and hit the notification bell to stay up to date on all our future videos.